Okay, so welcome to the Hauptwerk hardware how-to tutorial on soldering. Obviously, if we're going to be soldering, there are a few things that we are going to need. Firstly, we're going to need some solder, and I've got three different examples of some solder here, and we're going to need a soldering iron, which we've also got. So we'll jump straight into it really and just discuss these things first. So first of all, with the solder itself, this is some very old solder that I found laying around in my workshop. I don't know how well you can see it there. It's Erzin multi-core 3-core solder. It's about 2mm in diameter, and it's got 3 cores, as it suggests in the name, of flux, which are actually manufactured inside the solder. They run down inside the solder. So as you melt the solder with the soldering iron, obviously the metal itself melts. The alloy of this one is 60% tin and 40% lead, and that melts with the heat of the soldering iron, but the flux also melts, and that helps the solder to run across the joint and to make a good joint. So this stuff's pretty good, but it's much too big for what we use. It's also got lead in it, so it's I think the health and safety people might get a bit upset, and it's kind of just too old really for what we're doing. But it does illustrate the fact that it's got these 3 cores of flux which run down inside it. So moving on to something a bit more modern, if we take a look at this one, this is much thinner. This is 0.7mm diameter. This stuff's come from RS Components. This one is still tin and lead. It's 60-40 tin and lead mix, but it is much thinner, so it's more appropriate for what we're using it for. However, because it's much thinner, the cores of flux inside are correspondingly smaller. So you do need to get quite a lot of it on there if you're soldering wire before you've got enough flux for it to flow properly over the joint. It's actually more appropriate for small components onto circuit boards, and I think that's probably more what it's made for. So we'll move on from that one. The final one that I've got here is lead-free solder. This is, I think it's 96% or so of tin, and a small amount of copper and various other metals in the alloy. Again, it's got flux down the middle of it, but because it doesn't have lead in it, it melts at a slightly higher temperature than the original solder, so you do have to keep the iron on it for a little bit longer, or if you've got an iron that's adjustable, has an adjustable temperature, you need to turn the temperature up a little bit higher. But this is the modern stuff to use. This one comes from Maplin's. It's not expensive. It's got their little number on the back there, N29AR. So that's what I would suggest using. This is 1mm diameter, so not too big, not too small, just about right really for the jobs that we're using it for in our organ. So moving on to the soldering iron, this is my soldering iron. This is it's made by a company called Weller. I think the name's pretty much worn off the handle now, to be honest. I've had this, it seems like forever. I think I was issued with this when I first got my first job, and I was employed as a trainee, which was about 40 something years ago. So it's done pretty well. It's temperature controlled and it's 45 watts, so you can leave this on all day long, and that's pretty much what happens. It gets switched on in the morning when you come in the workshop, and it stays on all day long until you go home again. And I say it's been going forever and ever, and it just works. It has different tips available for it, so depending on what work you're doing, you can get larger or smaller tips. For the sort of thing that we're doing with the organs, you just want a very fine tip, which is what I've got on there. And the trick to success of soldering is to keep that tip clean and tinned. And I don't know if I bring that up to the camera how well this is going to show actually, but I think it looks pretty good. You can see that it's all nice and shiny on the end of the tip, and if I just take a little bit of solder and just touch it to it, it just melts immediately, because that's, it's nice and clean. If I touch it to other bits of it further back, which are not clean, even though it's just as hot, the solder just won't melt. It would be a nightmare to try and solder with that. So that brings us on to the stand really. These stands, again, they're super cheap. well, not super cheap I suppose, but they're reasonably cheap, and they usually have a space in them for some kind of sponge which you keep wet, and that just keeps the iron nice and clean. The steam cleans that tip, and it's good practice really, just to, every time you put the thing back or every time you get it out, just give it a little twist and a clean in there, and then just tin it with a little bit of solder, and then you're good to go for whatever the operation is that you're doing. But that is the trick to successful soldering, is keeping that tip nice and clean and shiny, and always tinned just with a little bit of solder on it, because that just protects it from the from oxidization from the oxygen in the air. So that's the soldering iron that I use. Obviously there are lots of different soldering irons available, and if you look again on places like Maplin or eBay, you can find all sorts of irons going from about 15 watts up to about 150 watts. If you get an iron that's not temperature controlled, one without a thermostat in it, for general work like we're doing on our organs, I would suggest you'd want to buy something like one of the Antex ones, which are generally around 25 watts. They do a little tiny one at 15 watts. That would be too small. It wouldn't get hot enough, or it wouldn't be able to heat up the wires enough for what we're doing. I would suggest about 25 watt would be fine. If you get a temperature controlled one with a thermostat, then I would think about 40 to 60 watts would be fine, because it won't overheat and it just gives you that little extra bit of power. So it depends on how much you want to spend. The important things to look for are that it has interchangeable tips, because as we looked at just now, these bits, I mean, where that's been sitting, and if you look at it now, it's kind of, if it's focused on there, it's hard to see on this little screen, but that's kind of got a bit dirty and grungy already just from the oxygen in the air, and every time we clean it and we put a little bit of solder on it, believe it or not, that does actually wear that tip away. Only very slightly, but it does wear it away. So they don't last forever, so you need an iron with interchangeable tips. There are some out there where you just have to kind of file away the top part of the tip and then tin it and go from there. They're not ideal. So have a look around. You can buy them, you know, they're not expensive. I think the Antex ones, 25 watts on Maplins, are about 25 quid, and that suggests that they'd be quite a lot cheaper on eBay. So that's the iron itself. Okay, just moving on to some other tools and bits and bobs which you may need to help you with the soldering operations that you're likely to come up against in converting or building an organ. So just to run through a few bits and pieces, you'll come across these things when you go looking for soldering. If you do a search on the internet, it's a flux pen. It's not appropriate for what we're doing. The flux is in the solder, so you definitely will not be needing one of those. So don't be tempted to buy one of those, because you're just going to be wasting your money. What is useful is one of these little things. It's actually a solder sucking device. It's just a little plunger. You push it down, and when you press the button, it pops back under a spring pressure. And inside, I don't know if you can see that, it's just a little plunger. So that's all it does, is it just sort of pops back in its cylinder with a replaceable tip. And the idea is that if you get too much solder onto something, you can just kind of put this on it and it'll suck the solder away. So just a quick demo of what I mean, and then if we can get this to how well it's going to work with this camera. It looks pretty good. Okay, so let's just have a quick go at this. If we put some solder on this board, so this is just a bit of Vera board, prototyping board. Okay, so I've got some solder on there now that's actually bridging two of the tracks. If we can go in a bit closer. So that would be something that may happen if you just apply too much solder to a joint. You may end up bridging across two pieces that you didn't want to bridge across. In the sort of context of our organs that we're building, there are pins that you have to solder the wires onto on the encoder board. So if you got too much solder on and you bridged across two pins, one of these solder sucking things would actually be quite useful. So it's simply a matter of, you heat the solder up with the iron, you put this thing next to it and pop, there you go. That's removed the solder from one track, the bridge is gone. we can do the same on the other track, and there we are. So it's actually quite a useful little gadget. The other thing you can use is a product called Solder Wick, which is kind of like a braided piece of wire with flux impregnated in it, and the idea of that is you just put that on there, heat it up, and the solder soaks into this solder wick. That works fine on flat surfaces like this bit of Veriboard, but it's not so good on kind of bigger surfaces like the or upright surfaces, like if you're soldering onto a pin. So on the other side of this board we've got a pin here. I should have left that zoomed in really, but let's have a look. Okay, so you can see that pin. If we soldered that wire onto there, yeah, happy days. But if there's a pin in the hole next door to it here, and we get too much solder on there, you could easily bridge those pins across, and it's just really easy using the solder sucker to take that solder away. So I would definitely recommend getting one of those. The other useful little gadget to have is one of these, they call them helping hands. It's just a heavy metal base with a bar and some crocodile clips that are kind of movable, and these are quite good if you don't have heat-proof fingers. You can just kind of use them to hold the piece of wire whilst you're tinning it, soldering it, or whatever, especially for soldering, you know, little bits onto, if you want to put the diodes onto the wires or whatever. Again, they're not expensive, and they do save you burning your fingers a little bit, so I would recommend one of those as well. So to look now at the actual soldering operation, if we take our little bit of test stuff here, which has got this pin on it. Again, I'll try and zoom in on that so we can see a bit better. If we want to solder a wire onto this, say we've got this wire here, I've just stripped back about 7mm of the insulation from the end. But what I like to do is, if you just twist the wire around, bearing in mind that these wires are cord wires, so they've got 7 thin pieces of wire. It's actually, they're 0.2mm diameter, and there are 7 of those. So if you don't twist them together, just looking at this bit that I've stripped back but not, you can kind of, they all go in different directions as soon as you start doing anything with it, and that would be a nightmare to try and solder. So I don't know how well you can see that, but if you twist them together, then the result is much easier to work with. So first thing I do is twist the wires together, then we get our solder and we just clean the tip of the iron and just tin the wire. So what that means is that we just heat it up and we just melt some solder over the wire, flick off any extra. So what we've got now is a tinned piece of wire. It's called tinning because solder is at least 60% tin, and we've now applied that tin to this wire, so it's now very stiff, but that's ready now to be soldered onto our pin. We also need to do the same to the pin, so we need to tin the pin, so exactly the same thing really. We heat the pin up and we just run some solder over it, and that's good to go. And then final thing to do is to take our wire, figure out some way of holding it against the pin. It's easy with one wire, and then we just heat the two up, and that is all we need to do. And there we are. So that wire is now soldered to that pin. It's a nice strong joint. What's also important when you look at the finished joint that you've made is that it should be nice and shiny. That's what we're aiming for. If it's a kind of a dull finish, then the joint hasn't made properly, and there's a good chance that, you know, if it's pulled around a few times, it will fail and fall off. So that's how we join a single wire to a single pin. All there is to it really. Okay, so the next thing to look at is how we join more than one wire to a single pin, or to anything else really. But the trick of that is, obviously if you've got 2 pieces of wire and you want to solder them both to the same pin, it gets a bit tricky because you run out of hands to hold everything in the iron and so on. So what we do is that before we twist these wires together, I mentioned just now that we strip the insulation off and then we twist them together to keep all the cores nice and straight together. You put the two pieces of wire together and you actually twist them together as a pair. So probably pretty obvious, but I thought I'd mention it anyway. So there we are, we now have those twisted together as a pair. They will happily fall apart the minute I put them down, but once we've twisted them together we can then get our solder and we can tin those as a pair twisted together. So there we are. The other thing about soldering, incidentally, is that you do have to make sure that it's hot enough. Most of the failures that I've seen where joints are not made properly, or where people say, oh, I can't solder, I've been trying and it's just not working for me, 9 times out of 10 it's because they don't get it hot enough. The solder has to flow right through into the centre of the this wire, which means that you have to have plenty of flux in there, and the whole thing has to be hot enough, the solder thin enough, molten enough, that it will just flow right into the joint. So it's kind of a bit of a knack, but have a play around with it. I mean, if you hold the iron on there so long that you start burning your fingers and that the plastic starts melting down here, well, you probably got it too hot, but equally it's really easy not to get it hot enough. So just something to bear in mind if you find that it's not going quite according to plan. So now, having soldered those two together, that's great. What has happened is where I've heated it up a bit more than for the single one, the insulation has run away a little bit down the wire from the heat. So I'm just going to snip the very end off so that we're down to about 5 or 6 millimeters, and that is about the same length as the pin. I don't know if that's, yeah, you can see that there. That's about 5-6 millimeters sticking out of the board. So to solder that onto there now, exactly the same as we did with the single wire, we just tin the pin and then we put our wire up against the side of it, which is hard to do without getting my way itself in the way of the camera. There we go. And so now the whole thing is soldered to the pin, both wires. So that's it really. You physically join them together first by twisting them, and then you tin them to hold them together, and then you tin the pin or the diode or whatever you're going to solder onto the end of them, or solder them on too in the case of the keyboard, and then you just apply a little bit of heat from the iron and away you go. And it's as simple as that really. So just to finish off with on our short tutorial here, I'm just going to solder the wires that we've been playing around with onto one of the pins on our real encoder board, or on the interface board. So I've already got the wires here that we just soldered together. Lots of pins as discussed in the other video, on our encoder board, which is where all of the wires from our organ connect to. But say we wanted to connect, say these wires are from our keyboards, and let's say that they're the first note of the keyboards, and we've got 2 wires because we've got 2 keyboards. So we've joined our wires together. Let's just pop them onto the pin that they would go onto. So this is the note 0 pin. There are 3 rows of pins which do the same thing, so I use the middle one. It's easy to get to. Note 0, and we just solder that onto there. Easy peasy. And you can see hopefully how that works. So that's sort of the point of our little tutorial today, is just so you know how to solder the wires onto these pins or onto the keyboards, and I hope it's been helpful.